So we are going to go over our for our test this Thursday. It is over Unit 3 and Unit 4. So Unit 3, we multiplied and divide fractions and decimals. And then Unit 4, we add, subtract, multiply, and divide all integers. And remember, integers are your positive numbers, your negative numbers, and 0. So let's jump into it. So it says a seamstress wants to cut ribbon that is 2/3 feet long into pieces that are 7/16 feet long. The seamstress, and I'm going to circle these because we're in math class, we circle our numbers. The seamstress will use the expression shown, so right here, this expression, to calculate the number of pieces that can be cut from the board, which expression can also be used to calculate the number of pieces that is cut from ribbon. So it looks here, I've got some that are multiplying and some that are dividing. So remember when we divide fractions, it's really blurry, sorry, but when we divide fractions, we do the method keep, change, flip, or since we're big 6th graders now, we say keep, change, reciprocal. That means the same thing. So I'm going to keep my first number, so 2/3, change my division sign to a multiplication sign, and flip or do the reciprocal of my second fraction, so 16/7. So I'm looking for an answer choice that looks like that. So when I look, this has 7/16. They forgot to flip it, so that one's wrong. This one looks good. Remember that dot is the correct way to do the multiplication sign. So y'all used to do the X like I did here, so I probably should have written this with a dot instead. That dot also means multiplication. This one they flipped 3/2. So that was not right, and this one still has a division sign, so that one's not right. So the correct answer would be B. So keep, change, flip, or keep, change, reciprocal. Okay, number next. Which expression below is equivalent? So same thing. We're going to do keep, change, reciprocal, or keep, change, flip. Keep 6/8, the same. Change the division to a multiplication. I'm going to use the dot. And this time I'm going to use the X, so I just can't get it right. And then 12/16, we're going to flip and do 16/12. So I'm looking for one that looks like that. This one has 12/16, so that's wrong. This one has a division sign. We need multiplication. This one has 6/8 and 16/12 with multiplication, so it looks like C is the correct answer. So just keep, change, flip, or keep, change, reciprocal. This one says, which statement about 7 multiplied by 5/7 must be true? So I'm starting with 7 and I'm multiplying by 5/7. Notice that 5/7 is less than 1. I know that all fractions are less than 1 if they're just a regular fraction where your numerator is smaller than your denominator. Now, if you had an improper fraction like 9/3, where your numerator is bigger than your denominator, then it'd be bigger than 1. But ours is normal. 5 is smaller than 7. So I know that this fraction is less than 1. So if I multiply by something less than 1, it's going to make my original number smaller. So 7 is going to get smaller. If I were multiplying by something greater than 1, 7 would get bigger. So since we're doing less, it's going to get smaller. So this one says the product is between 7 and 8. Well, if I'm starting with 7, if it's between 7 and 8, that means it's getting bigger, which is not true. This says the product's less than 5/7. It's not less than 5/7. It's going to be less than 7. So that's not right. The product is between 5/7 and 7. That could be it. And this one says the product's greater than 8. Well, it's not getting bigger. Remember, it's getting smaller. So it looks like it's going to be C. Okay, number 5. Which statement describes the value of the expression? So again, I'm starting with 54, and I'm multiplying by something that is less than 1. It's a regular old fraction, less than 1. So I know that 54 is going to get smaller. So the value's got to be smaller than 54, which is what A says. So it looks like it could be right. It's not going to be equal. We're dividing, or we're multiplying by something smaller, so it's going to get smaller. Value's greater. Nope. This one says the value is greater than 0 but less than 1. That's not right either. So it is going to be A. The value is less than 54 because it's getting multiplied by something less than 1. So it's going to get smaller. Okay, this one says which expression can be represented by the number line? So we are doing the hops. Every time you see the hops, that means multiplication. So any of them that aren't multiplying, get rid of them. Well, that's all of them. Plus division. So we're down to 4 times 5, which is our answer. But if you had multiple 4 times or multiplication problems you were trying to figure out, remember you're going to count how many hops you're taking. So 1, 2, 3, 4, 5 hops. Okay. And then in between each hop, how many spaces am I going? 1, 2, 3, 4. So I'm going from 0 to 4. So it's going to be, I'm jumping 4 spaces 5 times. So 4 times 5. And remember with the parentheses, that's another way to write multiplication. So always count the jumps and the spaces you are jumping over each time. So 4 times 5. And remember, adding or subtracting is going to be the straight lines where it goes like this and goes backwards. That's adding and subtracting. Jumps are always multiply. Oh, look, there's one right there. So this one's adding or subtracting. So any of them that say multiply or divide, get rid of them. They're all adding or subtracting. So we're going to keep them all. I start with whichever one starts at 0. So like the blue one starts at 0, so that's where I'm starting with. So the blue goes all the way here to positive 7. So my first number should be positive 7. Well, this has 0 as my first number, and this has negative 9, so these are out. Okay? Then from there, I'm going backwards to the left, so that means I'm doing a negative number. I'm adding a negative number, and I'm adding a negative number of, well, I started at 7, and I'm going back to negative 2. So I went back 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So I went backwards 9 times. So this is a positive 9 where this is a negative 9. So it's going to be B because I'm going to the left toward all these negative numbers. I'm going back. So negative 9. So 7 plus negative 9. Okay, this one says the circles in the model represent positive and negative units. Which equation is true based on the model? So we have the colored in ones are negative 1 and the non-colored ones are positive 1. So I have 3 negatives and I have 1, 2, 3, 4, 5 positives. So I have negative 3 and positive 5. So we're combining those together. So negative 3, plus positive 5. And when I do team positive and team negative, I've got 5 on positive, negative 3 on negative. Well, 5 trumps. It's the winner, so I take my winner, subtract my loser, and I get 2. Team positive wins, so it's positive 2. So I'm looking for something that looks like this. And it could be reversed. It could have like 5 plus negative 3, but it means the same thing. So now my answer is positive 2. These have negative 2, so these are out. And then this one has a negative 5 and a positive 3. I need a negative 3 and a positive 5, so the correct answer is B. Hide that on there. Okay. So just be really careful. Make sure you know what your key is. Make sure you look at this and know, okay, the colored are negative, the not colored are positive. Okay? What is the value? We're dividing fractions. Our method is keep, change, flip, or keep, change, reciprocal. So I'm going to keep 7/18. Change my division to multiplication. And do the reciprocal or flip the second fraction. So my numerator becomes my denominator becomes my numerator. Now I'm multiplying fractions, which is so nice because I just multiply straight across. 7 times 5 is 35. And 18 times 4, if you don't know that off the top of your head, you can come over here and multiply it out. I know that 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7, so 72. So I have 35 over, go back, 72, which is answer choice D. So multiply tops by tops. Bottoms by bottoms. That's all you have to do for multiplication of fractions. Okay? A scientist put 6 and 216 thousandths ounces of chemical solution into beakers. She put 56 thousandths ounces of the chemical solution into each beaker. How many beakers did the scientists use for the chemical solution? So remember, if we are looking for the total, we multiply. If we have the total, we divide. Okay? This is what we're going to always come back to. So I've got 6 and 2/16 ounces. That's the total I have. So that's my total, which means I'm going to divide because I have the total. So I gotta give myself some space here. I'm going to divide 6.216. Okay, that's my total. He goes in the house. And then 0.056. Okay, so remember when we divide with decimals, we can never have a decimal on the outside. So we put our ball to the wall. I got to move it over three times. So whatever I do on the outside, I got to do on the inside. Move it on the inside, and then I raise the roof, I bring it up, and put my decimal. Now I divide like normal, okay? And I'm saying, okay, how many times is 56 going to 6? Well, it can't. So I'm going to put an X, or you can put a 0. Then I say, how many times can 56 go into 62? I know one time. So then I subtract. I can't do 2 minus 6, so I'm going to borrow. 12 minus 6 is 6. 5 minus 5 is 0. 6 is smaller than 56, so we're good. Now I'm going to bring down my 1, and I know 56 can go into 61 one time. So I'm going to do 61 minus 56. I'm going to make this a 5, this an 11. 11 minus 6 is 5. 5 minus 5 is 0. Then I'm going to bring down my 6. 56 goes into 56 one time, and that's exactly. So my answer should be 111. Oops, zoomed out too far, which is answer choice D. Answer choice D. So again, always ask yourself the question, if I'm looking for the total, I multiply these two numbers. If I have the total, I divide the two numbers. And we had to divide because we had the total. Okay, let's look at the next one. Barrett feeds his horse 1.2 pounds of sweet food every day. How many servings are there in a 14 64/100 pound bag of horse food? So, do I have the total horse food? No. I mean, yes, I do have the total horse food, right? It's right here. I've got the total horse food is this much. And each time I'm feeding it 1.2. So I'm going to take the 14.64 in the house. And then 1.2 goes outside. And we have to do the same rules. So no decimals on the outside, so ball to the wall, move it over. If I moved over one time outside, I got to move it over one time inside. Then I'm going to raise the roof. So now I say, okay, can 12 go into 1? No. So I put an X or a 0. Can 12 go into 14? Yes, one time. 12 times 1 is 12. Then I have 4 minus 2 is 2. 1 minus 1 is 0. Then I can bring down my 6. Okay, 12 can go into 26 2 times. 12 times 2 is 24. 6 minus 4 is 2. 2 minus 2 is 0. Then I bring down the 4. 12 goes into 24 2 times. So 24 minus 24 is 0. So my answer should be 12.2. So there's 12.2 servings, or 12 and 2/10, which is answer choice D. Okay. So look at this next one. My dog weighs 2 50 pounds. The vet said he should weigh 3 14 times his weight at the end of 12 months. How many pounds will he weigh at the end of 12 months? So I don't have the total he's going to weigh at the end. So I'm looking for the total, so I'm going to multiply. Plus it says the word times, so we're multiplying these two numbers. So I've got 3.14 times 2.50. Okay, so 0 times all of this is just going to be 0, yes? Then when I go down and I do 5, I have to add a placeholder 0. 5 times 4 is 20. 5 times 1 is 5, plus 2 is 7. 5 times 3 is 15. Okay, now I have 2 placeholder zeros that I have to add. And I can cross off this 2. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Now I add up everything. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 7 plus 8 is 15. Put the 5 down here. Carry the 1. 1 plus 5 is 6. Plus 2 is 8. And 1 plus 6 is 7. Okay, now remember with multiplication, we got to go back and count our kids in our car. So in our first car, we have 2 numbers after the decimal. In our second car, we have 2 numbers after our decimal. So together, we have 4 kids in our last car. So I got to move my decimal over to have 4 kids. So 7 and 85 hundredths. And I can get rid of these zeros. Remember, after the decimal, I don't need them. They don't change the place value. I could add them or I could get rid of them. So I'm just going to keep it like this. 7.85, which is answer choice D. Okay. What is the value of the following equation? So I have $4.80 times 3 4/5. Okay, they're in different forms, so I either need to get them all to fractions or all to decimals. I say let's just go ahead and turn the mixed number into a decimal. You could do it the other way, however you want to do it. So in order to turn a mixed number, first I have to do the Texas two-step. And honestly, actually, I probably wouldn't even do that. I'll show you that way in just a second. But remember, we know our benchmark fraction, so I have 3 is my big number, and then whatever this little fraction is, that's my little pieces. That's going to be my decimal part. In 4/5, I just take the numerator and times it by 2 anytime I have a 5 on bottom. So 4 times 2 would be 8. So this would be 3.8. Okay. Or if you did the Texas two-step and turn this into improper fraction, 3 times 5 is 15, plus 4 would be 19 over 5. Then you could divide it out. 19, numerator in, denominator out. 5 goes into 19 3 times. 3 times 5 is 15. 9 minus 5 is 4. Then I have to add a 0, but if I add a 0, I've got to add a decimal. Bring down my 0. 5 goes into 48 times. So either way works, whichever way you would want to do it. So now I have $4.80 and 3.8. Okay, so 8 times 0 is 0. 8 times 8 is 64. 8 times 4 is 32, plus 6 is 38. Then I have to add my 0 placeholder. Scratch this off. 3 times 0 is 0. 3 times 8 is 24. 3 times 4 is 12, plus 2 is 14. Add it up. 0 plus 0 is 0. 4 plus 0 is 4. 8 plus 4 is 12. 1 plus 3 is 4. Plus 4 is 8. And then bring down the 1. Then I count my kids in my car. I've got 2 kids in this car and 1 kid in this car. 2 plus 1 is 3. So I should have 3 kids in this final car. And again, I don't really need the 0, so I can just say $18.24. Okay. This one says Cameron bought 10 markers for $3 each and spent $8 on a new notebook. He paid for the markers in the notebook using a debit card. The charge in the balance of Cameron's checking account can be represented by the expression below. Which integer represents the change in balance of Cameron's checking account from these purchases? So here's our expression. I'm going to rewrite it down here so we have a little bit more room. So 10 times -3 plus -8. Okay, so we've got multiple operations happening, so we have to follow order of operations, which is GMDOS. Okay, we do grouping symbols first, exponents, then we've got multiplication and division. Now, multiplication doesn't always go first. Remember, these are from left to right. So if multiplication comes first in the problem, we do multiplication first. If division comes first in the problem, we do division first. Same thing with addition and subtraction. Okay, so I've got multiplication. Remember, this is multiplication if there's parentheses and there's nothing in between. And then I also have addition. So multiplication obviously comes first. So I'm going to do 10 times -3. Okay, so remember we're going to multiply right regular. So 10 times 3 is 30. And then we do our Dorito Man to figure out the sign. So I had a positive and I had a negative. So my leftover piece is negative. So my final answer needs to be -30. Okay, and then I'm going to bring down plus -8. Okay, so then I'm doing my team positive, team negative. Notice these are both going to go on team negative. They're both on the negative. So all I have to do is add them up. 0 plus 8 is 8. Bring down 3, and I keep the sign. So -38 should be my answer. Just make sure we follow those order of operations. That is A. Answer choice A. Okay. Casey is playing a math game. She chooses 3 cards. The value of each of her cards is shown. What is the sum of the 3 values of the cards? So first we have to know what sum means. Sum means to add. So we're adding up -15 plus 2 plus -4. So we're doing team positive versus team negative. So on team positive I have 2. Team negative I have -15 and -4. So I add up my team's totals. This guy's just 2. There's only one number. 5 plus 4 is 9. Bring down the 1. So -19. So if I forget about the negative for a second and I say team positive scored 2 points, team negative scored 19, who won? Obviously team negative won by a lot. So I take my winning team and subtract my losing team. 9 minus 2 is 7. Bring down the 1. And it's going to stay negative because team negative won. So my answer should be -17. Okay. This one says, which expression has a value of -32? These are so ugly because they make you do 4 problems in one. How gross. So we really have to work out each one and figure out which one is going to be equal to -32. So we got to follow GMDOS. So first step is to divide because I've got a subtraction, I've got a plus, and I've got a division. So in GMDOS, division is going to go first. So 33 divided by 3 is 11. If we do our Dorito Man, I have a positive 33 and a -3. So my answer should be negative. And I'm going to copy everything else down. Keep it all lined up nice and pretty. Make sure your work stays pretty. Now I've got subtraction and addition. I'm going to follow order of operations. Okay, so I've got a minus sign. When I have subtraction, we have to do keep, change, opposite. Keep, change, opposite. So that's what I'm going to do next. I'm going to keep 18, change the minus to a plus, and opposite of -45 is +45. So I really have just 18 plus 45. So we got to come over here and do that. 8 plus 5 is 13. 1 plus 1 is 2. Plus 4 is 6. So 63. And then plus -11. Okay, these are different signs. So they're going to be on different teams. So I'm going to be subtracting them. So So when I do 63 minus 11, I get 52, and it's positive because team positive won. And that's not what I wanted. I wanted negative 32, so that would not be the answer. Okay, next one. Okay, these are all, I've got addition, subtraction, and subtraction. So I just have to move from left to right. Okay, so first I've got both on team negative, so all I have to do is add them. Same signs add, different signs subtract. 3 plus 2 is 5, and keep them on team negative. Then I'm going to rewrite everything. Keep going from left to right. This one is a subtraction, so keep, change, opposite. Keep negative 5, change the minus to a plus. Opposite of negative 18 is positive 18. So then I've got negative 5 plus 18. They're on different teams, so I subtract 18 minus 5. 8 minus 5 is 3. Bring down the 1. So it's a 13, and team positive was our winner, so it's going to stay positive. And then 13 minus 1 is 12. And that is not what I wanted. I wanted negative 32, so that is not the right answer. I told y'all this was mean, y'all. They make you get, I'll do 4 problems in just one. Okay, this time I've got a multiplication and I've got a subtraction. Multiplication comes first, according to GymDOS. So 6 times 3 is 18. When I do my Dorito Man, I have a negative and a positive, so my answer's got to be negative. Copy down the rest of the problem. I'm subtracting, so I have to do keep, change, opposite. So negative 18 plus opposite of negative 15 is positive 15. They're on different teams, so I subtract. 18 minus 15 is 3, and I keep the negative because team negative won, so negative 3. And again, that's not my answer because I'm looking for negative 32. Okay, last one. Hopefully this is it. Okay. So I've got grouping symbols, and then I've also got this minus sign. So I got to do grouping first. So 5 times 2. I have this negative hanging out, and he just gets brought down. So 5 times 2 is 10. And this negative gets brought down, minus 22. Now I'm going to KCO it. Negative 10, keep. Minus, change to a plus. Opposite of negative, or positive 22 is negative 22. They're same signs. They're both on team negative, so I add them. So I get 32, and they're both on team negative, so I keep it negative 32, which is our answer, finally. And honestly, I'd probably start with answer choice D because star is mean, and they are going to probably put the correct answer very last, so they make you work out the whole problem, all 4 problems. So that's what I would do. Okay. Again, we're doing GymDOS, what we just did 4 times. You get to do it again. Order of operations. So I've got parentheses with division, so that's going to go first. 15 divided by 5 is 3. Dorito Man. I used a minus and a plus, so I'm left with a negative. Copy everything else down. Remember, when I have 2 parentheses next to each other and no sign in the middle, that means multiply, so he's next before I do anything else. So 4 times 9 is going to be 36. And then one's positive, one negative, so it's going to be negative again. And then copy everything else down. So now I get to keep, change, opposite. So keep, change, opposite. They're on different teams, so I subtract. 36 minus 3 is 33. And I'm going to keep it positive because team positive won. So this is positive 33, which is our answer. Okay. Okay, these last couple are going to be ordering. So this is a review of what we've done before. So we're going to be ordering in descending and ascending order. It says the table shows the completion time of 4 runners in a race, which list shows the runners in order by the completion time from fastest to slowest. So remember, in a race, if you finish just fast, your time's going to be lower than my time. So we're going from least to greatest. It's always kind of confusing. So you least to greatest. So first I'm going to make my ladder, and I'm just going to kind of extend on from here. And I've got to get these all in the same format. So I think I'm going to do decimals. So I've got 12, and then the fraction 1/2 is just 50 cents, right? This is already a decimal, so I'm going to keep him. Again, I'm going to keep 12. Remember, if I have a 5 on bottom, multiply the top by 2. 2 times 2 is 4. And then I'm going to add a placeholder 0 because this guy went to 2 decimal places. And then 12 and 8/10. And again, I'm just going to add a 0 because that other guy went to 2 decimal places. So I'm going to least to greatest. So I'm finding the smallest. They're not negative, so I don't have to flip my brain or anything. So let's look. They're all 12, so I'm going to start looking in this tenths place. So the smallest one is going to be the one with the 0. So he's first. Then the 4. Then the 5. Then the 8. So if I were to put these in order, I would have Ellen, Steve, Joe, and Patty. Ellen, Steve, Joe, Patty, which is answer choice C. So just be really careful when it says time. If it's going fastest to slowest, it's looking from least to greatest. You got to think about it. If I win the race, I'm going to have the smallest time, and I'm the winner. Okay? Which shows the temperatures in order from coldest to warmest. So think about it. If it's 100 degrees outside, it's really, really hot. But if it's 20 degrees, it's really, really cold. So coldest to warmest is least to greatest. So I'm going to pick one of these answer choices and make a ladder. I've got -20, 18, -15, and 10. So I don't have to do any conversions. They're all integers. We're good. So now I just have to order. Again, I'm going from least to greatest, so I know that negatives go first. Negatives are going to be my coldest. They're farther to the left. So my 2 negatives are these. I have to flip my brain because I'm thinking, okay, the one farthest away from 0, more to the left, is the less one, which is actually -20. That's going to be colder than -15. So that's second. Now I don't have to flip my brain anymore. Now I just think regular. Which one's smaller, 10 or 18? 10, and then 18. So that's the list I'm looking for. I'm looking for -20, then -15, then 10, and then 18. So we're looking for that. So this doesn't have negatives first, so he's out. -20. This one has a negative, and then a positive, and then a negative. He's out. It looks like answer choice C is it. Notice on this one they flip the negatives because a lot of people do that. Be really, really careful with those negatives. The bigger the negative, the smaller it is. You got to flip your brain. Okay. This one, Emma will use 6 different types of wires on a science project. The fractions represented the diameters of these wires in inches, which list shows the diameters of the wires from least to greatest, L to G, least to greatest. Okay, so again, we got to make a ladder because we're going to have to do some converting. So I have 7/16, 1/2, 3/8, 9/32, 5/16, and 15/32. Okay, so these are all fractions. So I think I'm going to get a common denominator, and I can see if I can multiply by something to get to 32. So the ones that are already 32, I'm just going to go ahead and rewrite because they're done. So 9/32 is going to stay, and 15/32 is going to stay. I can multiply 16 by 2 to get 32, and whatever I do on bottom, I got to do on top. So 7 times 2 is 14. Okay, 2 times 16 equals 32. Whatever I do on bottom, I got to do on top. 1 times 16 is 16. Then I've got 8 times 4 equals 32. Whatever I do on bottom, do on top. 3 times 4 is 12. And then 16 times 2 equals 32. Whatever I do on bottom, do on top. 5 times 2 is 10. So now they all have common denominators, so I'm just looking at the numerator. And I'm ordering them just like normal from least to greatest. There's no negatives or anything, so I can just go normal. So smallest one is going to be 9, then 10, then we've got 12, 14, 15, and 16. So when I'm ordering these, I'm going to go back to my original. So I've got 9 over 32 is first, then 5/16, then 3/8, then 7/16, then 15 over 32, and then 1/2. So that's what I'm looking for. So it looks like, nope, 5/16, 3/8. Looks like that is answer choice D. So make sure you do your ladders, make sure they're nice and neat. If you didn't want to get common denominators, remember you could always turn them into decimals. So you would just have to do a lot of needling. I thought that would probably be a little bit easier. So if you have a bunch of fractions, check and see if you can get a common denominator. Okay, this one. 5 points are labeled on the number line. Which point would describe point L? So we're looking, where would this be? So first off, notice it's going from 0 to 0.5. And I'm going to go ahead and do 50. So it's going from 0 to 50 cents. So in between, it looks like I'm counting by 5 cents. So this would be 0.05, 0.10, 0.15, 0.20, 0.25, 0.30, 0.40, 0.45, am I off? 5, 10, 15, 20, 25, 30. Oh, y'all, I can't count. 30, then 0.35, then 0.40, then 0.45, then 0.50. Whew, okay. So then I've got to see, okay, point L is at 0.30, but these are in fractions. So good thing I know my benchmarks. I know 3/4 is 0.75. Well, that's not even on my number line, so that's out. 1/4 is 0.25, which is really close, but that's not what I want. 1/10 is literally a 1 in the tens place, right? And I'm going to add an extra 0 because that's what we have, and that's not anywhere close to what I want. And then 3/10 is literally a 3 in the tens place, and again, I'm going to add an extra 0 because I put an extra 0 here, and that's what we want. Okay, that is it. That's your review. So a couple of the ordering, and the rest of it is all integers and multiplying and dividing fractions and decimals. I hope this helped. Please study. Let me know if you have any questions. Bye, y'all. Y'all have a great rest of your night.